Earlier what we want to do was we want to find the equation for a plane. But what we could do instead is we could instead say we want to parametrize it. This, like we were discussing in the first lecture, this equation is descriptive. It makes it easy to figure out if a point is on the plane, but it doesn't make it easy to construct a list of all the points on the plane. What we'd like to do instead is we'd like to parameterize it. So we would like to basically construct a little coordinate system that says, hey, this plane floating in space somewhere, maybe I'm going to take this point here and I'm going to call that the origin 0, 0. And maybe I'll call this point over here 1, 0, and I'll call this point over here 0, 1, and then extend those coordinates out in both directions so that if I pick some random point over here, I can express it in terms of that coordinate geometry. That's what a parameterization for a plane is usually going to accomplish for us. It makes it easy to say, if I want a list of all the points on the plane, there are all the ways to plug in a point and northeast coordinate into this parameterization. So to parameterize a plane, there's a simple way to do it, or there's a simplest possible way to do it. What we need to do is we need to take the equation and we solve for one of the other variables in terms of the other two. So here, what we could do is we could say, let's take this equation and solve it for the variable z. We say, let's move z over to the other side and then divide by its leading coefficient. And when we solve, we'd be left with this equation that describes z as a function of x and y. And then we can parameterize our plane by plugging it back in. We say that we get a function of two variables that takes in two variables, x and y, and gives us back three variables, x, y, and z, giving us a way to find every single point on the plane by plugging in different values of x and y, like so. Now, there are some disadvantages to writing it that way, and I'm going to try and be a little bit careful when we do that in this course. When we do that, we are kind of confusing our coordinates for the source, our map coordinates, with our x, y, and z coordinates, our coordinates inside three-dimensional space. So usually, when I write a parameterization of a plane, I'm going to give different names to our parameters. I'm not going to call them x and y, even if they happen to be the same thing. So here what I've done is I've written a way to say, okay, a list of every point on this plane is given by all the possible triples, u comma v comma 2u plus 3v plus 5 over 4, as u and v vary. So if I plug in u equals 1 and v equals 3, then I'll get a point 1 comma 3 comma 10 over 4, and that's going to be one point on the plane. And I could get any other point I wanted on this plane by plugging in different values of u and v. I'm just trying to be careful about not confusing my coordinates and my coordinates inside three-dimensional space. All right.